All right, 1.3. So we dealt with how we think of data as far as numbers and non-numbers, right? So now we're going to deal with how we collect data, how we do the collection of that, or how we set up an experiment, which is kind of important here. I mean, go like this. A little better to see a few things. So let's jam with it here. So I'm going to skip that. 1 second here. This, and this. And let's just go all the way to here. One 1.3, a little bit of a long section. A little bit of talking about stuff. All right, so first things first, how do we do stuff? How do we collect the data? We do it by an observational study. Just means the person looks at something, they observe what's happening, they measure it, they figure the characteristics of something as part of a population. This would be anything that we observe. So we're not setting up an experiment here, we're just observing is something taking place. So researchers, one study, that was funny, they gave us, they're just observing kids and trying to figure out if there is, sorry, that's an experiment, sorry. Let's see, try to think of a study here. Study that usually something that happens in nature, so that happens naturally as opposed to sustained environment here. One statistics I'll show you a little bit later is let's see, in Barnstable, Massachusetts, in July they had a COVID outbreak just in that small little city, just a county, right? So we gathered a whole bunch of data there, and that would be observational study because it happened naturally. We're just observing the numbers that happen. All right, another one, don't write this down, but here it is. Research that measured the amount of time people spent doing various activities. That's kind of what you do, such as paid work, childcare, socializing. And the U.S. Bureau of Labor Statistics probably is the biggest statistics company in the United States right there. They gather data about a whole bunch of stuff. So the highlighted sections, if you want to copy the non-highlighted sections, are the ones I'm kind of giving examples, but you don't really need to write stuff down. Okay, that's observational study. Bam. Next is now the experiment. This is when you actually set up stuff. You make an environment where certain things happen. So an experiment is a treatment. Is it applied to part of the population? That treatment is called the treatment group. Hey, good names, good labels. And then you see the responses that have been observed. Then you have another part of the population we call the control group, in which no treatment is applied. So there's your two groups. The subjects in both groups are actually called experimental units. Experimenting on them. And in many, many cases, subjects in the control group, let's modify are given a placebo. Something fake, something that's not. Lots of writing. Sorry, guys. So however you want to write it down, write it out for yourself. We'll talk about the placebo effect. So there it is. You're setting up the study. Now, let's do this here. Experiment was conducted. What they did is they had school children right before recess. One class was given a whole bunch of sugar before recess. One group was given like no sugar, right? Regular food. And then they went out to recess to play. Then you had psychologists or teachers, right? They would go and sort of observe the activities of the kids. And the question was whether or not sugar contributes to extra activity. And you know, it's so funny when the statistics, they set up these studies, right? We're going to find this out. But like, you just ask a parent, hey, if you give your kids sugar, if they could be more hyperactive, that's pretty easy. Did I tell you guys about the horror movie before I go to bed? Okay, so there's the other. I'm teaching 4 statistics classes, so I forget who I tell what. So if I repeat something, just say, Mr. G, if you repeat that. All right, so number two is experiment. Lots of writing here, so I'll wait just a little bit here. Tell me if I'm going too fast as well. Right? But reading these reminds me of that code. Oh, wow, yeah. So related to, at least nowadays, yeah, with all the stuff you hear all the time, right? Study, this, then this. Very much a lot of sciencey words that are trying to explain stuff. Okay, experiment, that's number 2. Let's do just a quick example here just for us here. Let's go to this here. Tell me, observational study or experiment? That's what I mean. So here it is. Research studied the effect of vitamin D among patients with antibody deficiency or frequent respiratory tract infections. So 70 patients received 5,000 international units of vitamin D daily for a year. Another group receives a placebo. It's fake. Experiment or observational study? Let's go with show of hands. How many say observational study? 1, 2. Okay. How many say experiment? 1, 2, 3, 4, 5, 6, 7. And how many are still asleep? All right, good. So yes, this would be an experiment because they're not just observing something that's happening in nature. They've actually created an environment, right? They said, hey, look, we're going to take a few people. We're going to give some of them 4,000 international units of vitamin D, and some of them will not. We're good? And so they are sort of setting up the process. We're good? Talk to me because this is for you guys here. So this would be an experiment. And of course, number 2, what do you guys say? Research conduct a study. Determine how confident Americans are in the economy. So research then called 3,440 US adults and just ask them, rate the economy. Is it doing good? Is it doing bad? Is it doing better or worse? Experiment or study or observation? All right, show of hands real quick here. How many say observational study? Raise your hand for observational study. Hands down. How many say experiment? If that is an experiment, totally. And the answer is observational study. They didn't give one part nothing, right, and one part something, right? They didn't do that, right? They just called and asked a question. There it is. There's a. Okay, so we got observational study. We got experiment. Number 3. Number 3 is something called a simulation. So now that we have high-tech computers do stuff for us, what we tend to do is we tend to simulate. It uses a mathematical or physical model to reproduce. They stuff all the conditions into it, and they try to see if it's going to work. Let's see, where I've seen it work good is our weather apps nowadays. It is so interesting. You know, it says, you know, per hour, we can figure out the weather per hour. Especially when a storm is coming or is coming or is happening. They'll say, you know, in 30 minutes, the storm will subside, right? On your weather app. And sure enough, right about that time, it does do that. They're plugging in coordinates, they're plugging in everything else in order to figure out a storm will end. Let's see, where it was done bad, I think, in my opinion, was remember when, let's see, when Al Gore, I don't know if you guys were around, when Al Gore presented the movie of just a climate change movie. Not that it gets climate change, but in that movie, they did a simulation which, like, the polar ice caps are melting, right? The polar bears are going to be out of the ocean, right? That was based upon a simulation. Simulation of them putting in the input saying, hey, in so many years, that's going to happen. And so sometimes simulations aren't correct because predictions don't come true. Because you did not put every single condition in. Okay, anyways, don't need to write this down, but usually involves computers. Sometimes impractical to create a full entire real life situation. We do this sometimes because it saves money and time, as opposed to sometimes waiting 20 years to say, hey, that didn't happen. Okay, and the best example here probably is automobile manufacturers simulate dummies and what's going to happen in crashes, right? There it is. It's a whole bunch of computer programming and to see what happens to the human body at a 60 miles per hour crash. Okay, and last one. Last one of the type of stuff we do, surveys. And there's maybe we can kind of think of, I think the ones that are sort of close together are something called observational study, and then this is just a survey, right? Observational study is something that you observe, where this one is now you are setting up an interview, right? Okay, so there's the 4 stuff. That's the way we collect data right there. Let's jump into experiment a little bit more. So here's the one that we have to actually set up now. The one that we set up, we've got to be mindful of 3 things when we set this up. So 3 key elements of a well-designed experiment are, we have to figure out how to control all the variables we have. How do I randomize? And then if this can be replicated as well. So 3 key elements. And usually what happens is, especially with COVID these days, someone does an experiment and then the next video on YouTube is like, well, yeah, see, this experiment, it really didn't have a good control mechanism. So that's why this experiment is not really done well. I was watching last night, they were talking about randomization. Like, yeah, and we really did, the people here were not really randomizedly picked. They were not picked well. They were biased in this way. So control, randomization, and replication. Let's talk about each one of those, because that's an experiment, that's where things go wrong. And let's see what does go wrong here. So let's talk about control. What could go wrong and what do we do about it here? Let's see. So control, we have something called confounding variables. Which means there are more variables that are being looked at than the experimenter really could control. I think the best example would be like cholesterol medication. You can put a whole bunch of people on cholesterol medication, experiment design, but then you don't know like how many people are exercising, how many are not, right? How many are eating a whole bunch of sugar every single day, and how many just change their diet. So in order to do that, then the people have to agree, I'm going to eat this diet while I'm here, or I'm going to do this. I'm going to exercise this much and this much only. So that's a way to control the group here. So confounding variables. A good example from the textbook, which was pretty good. So coffee shop owner, what she does is she just remodeled her shop. And at the same time, a nearby mall just had its grand opening. So, oh no. Right, so the question is, was it because she remodeled her shop the business grew, or because the mall came in? Don't know how much between the two. Then you can't really tell. Okay, so one more thing for control is something called the placebo effect to look out for. Here's what happens. As the placebo effect occurs when subjects react favorably to the placebo. So the subjects really have a reaction they should not have. So in the 1970s, 60s and 70s, when psychology sort of took off quite a bit, and this whole process of doing experiments with the placebo pieces here with the treatments. So what happened in the 1960s and 70s, they would tell the person, you are having this cholesterol medication. You take this cholesterol medication for 3 weeks and we'll see what happens, right? And so we found this interesting thing. People that were taking the placebo actually had lower cholesterol. What is happening here? So about 1980s, experiment like that, they changed their wording. And what they did is they said, you may or may not be getting the treatment, right? So again, that kind of psychologically, that kind of just changed people's perspective on stuff. And so that is something called blinding. So we are just blinding the person from saying, hey, did I get it or did I not? I don't know. So that at least tries to get rid of the placebo effect. Is it completely true all the time? No, because people are like, yes, I did get the treatment. Let's go. Okay, so blinding, and then we actually also do blinding different ways. So just to give you so definition of blinding then on the side here. So blinding is a technique where the subject does not know whether he or she is receiving the treatment or receiving the placebo. Just sometimes it is just the how you present the study to the person. That's it. When I went to Fresno State, their psychology department was huge. They have a huge psychology department there. And so what happened was every maybe 2 or 3 weeks, there'd be some kind of psychology study that's happening. So what you would do is you would get money, any college kid, man, $5 is pretty good. So it was like $5 or $10 to enter this study, to do this experiment. So yeah, I went to a few of them. Usually it was just picking numbers, or it was like a memory test, whether you can remember stuff. And the one I was part of, it was if you cluster things together of known objects, can you remember more? That was the one I still remember. Right? If it's just a random list, how many things can you remember? And then you do another list, you go, you cluster the stuff together into clusters, and then you recall it 3 minutes later. Okay, and then this one is the surefire one that we usually use all the time. If you haven't done a double-blind experiment, it's not considered a true experiment really anymore. So here's what we do. We tell the people, you don't know if you're getting the treatment or placebo, and then the person that's observing the subjects, they don't know whether they got the treatment or placebo. So good example was the kids that were given sugar right before recess, and the kids were not given sugar. But then the teachers that were observing the kids, they did not know which one got sugar or not. So it kind of gives you this extra little barrier of saying, hey, we got rid of bias here whatsoever. Okay, so placebo effect, blinding, perfecto. Let's jump to, so that was the whole stuff about control, making sure that we have a control group, making sure we don't have other variables, sometimes even the observer, right, their bias in it. And that's an interesting thing there that happens. You still can't control full-on bias of any person, right? So then you try to minimize it as much as possible. They did an experiment, again, all this stuff here. They did an experiment in science and math classes. Not an experiment, actually, no, it was a study, relation study. So it was, the question is, how many times did the teacher call on the girls versus the boys in the classroom? And so they went to the science and math classes, and they found out that the teachers would actually call on the boys more often. And then they went to the English classes and the history classes, and they found out, again, a natural phenomenon was that they were calling on the girls in those classes. Right? So it's this inherent bias we have in our mind sometimes. So that's just another way to try to figure out how to undo it. So that wants that experience. Okay, randomization. Let's talk about this guy here. It's the process of randomly assigning people to the treatment group. And we kind of think like, no, duh. What you do is you just pick people. That's the best way to do it. It seems like maybe that's not the best way to do it. So let's go with it. So first thing is, there's one called the completely randomized design. So subjects are assigned to different treatment groups through random selection. And that's one way to do it. It's sometimes called a simple random design. You just pick people out of a hat, and the number, that's what you get. The other one is somehow you make it so that you at least have different blocks. So you divide the subjects into blocks first, and then within each block, then you randomly assign a treatment group. This one tends to be a little bit more effective. And we'll go into a little bit further into this one here. It's kind of wrap your head around this here. So completely randomized design. You just pick people. Block design, you separate them out first. And then within each group, you pick out all right, how does this work? Sorry, let's see about 4 people still writing. Don't work. There's a lot of writing on that page. Please do tell me if I'm going too fast. I don't want to go backwards on the slide. This is for you guys, not for me. All right, so let's start talking about this here. We'll do the next slide here. So random block design. If you just completely pick people out of a hat, let's say for this class here, right? Let's say we put all your names into a hat, and I want 3 students out of here. And so what I do is I just pick them, 1, 2, 3, and I want to look at your GPA as a just random. Where I'm going to give you an observation, right? How do you enjoy the class or not, right? It could be that I will pick all males, right? And if I do that, now my data is going to be skewed right away, right? Or even better yet, if I pick, I'll ask you guys here. So if I really want to truly see if you like the class or not, should I just randomly pick you, or should I kind of block it out so that I see a whole variation of students? So I'm thinking, if I do is if I can sort you guys according to your college GPA already, I actually would get much more of a full view. So it's kind of like the 4.0 students that everybody does not like, right? I pick one of you guys, right? Then I pick the B average student, and I pick the C average student, and the D average student, and then the F, right? By me picking that, now I have 5 people, and I'm getting a lot better of a view of my class, right? Than just randomly picking 3 people. So random block design, an example from the textbook. Here it is. Experimenter was trying to figure out the effects of a new weight loss drink. Again, don't need to write this down. Just let's talk about it. And so instead of just randomly picking everybody, this company decided, what we're going to do is we're going to just differentiate them between ages, right? Because sometimes diets are different at different ages. So the 39-year-olds may be a little bit more active than the 40 to 49-year-olds, right? And then the 50-year-olds, their metabolism has slowed down considerably, right? So you have that kind of thing. So then what we do is we divide them up into something that would make sense. So then we get a good understanding of this diet program. And then within each of those categories, those 10-year decades there, we figured a control group and a treatment group. Now I can see a lot better. So it could be the diet works for the 39-year-olds. Then the question is, why is it working for them, not the older ones? Maybe it's because the 39-year-olds are more active. A lot more active than the 40 to 50-year-olds. Okay, we're good there. So block design, way better as far as thinking of how we should. Okay, the other one that usually is done is something called the matched pairs design. So what you do is you take subjects that you have similarity between the two. And let's see, last night I was looking at a YouTube video and this was so cool. So what they did is they did a observational study for 8 months in Israel. And they're trying to figure out the side effects of the vaccine. So what they did is they matched up people one by one, people with the same, maybe like conditions. So same year, same health, how healthy they are, right? And one that took the vaccine and one that didn't take the vaccine. That's kind of how they, so it was a matched pair design. And so they went backwards in time. Oh, no, sorry. They selected them. It was an 8-month study. And then after 8 months, they found out of how many of those people had some kind of disease in the process, right? So it's kind of like you're looking for disease variants. And so after doing that, you see if like those certain pairs of people, one that did not take the vaccine didn't have those, one that did have some complications. So now that actually led Pfizer to actually put a warning label on their vaccines now. There's a warning label for heart, myocardium expansion, and pericardium expansion. So there's a help because of that, because that study they did for a while and figured, hey, this is someone's how. Anyway, cool stuff, fascinating stuff that actually we live inside of. Okay, that's randomization. There it is. Major ones is just simple. You just pick them out of a hat. Second one's the block design, which seems to be a better way to do it. And then sometimes the match pairs. Because we want to get as much similarity as possible. So let's jump to the next one. So now the question is, how do you repeat something? How do you replicate this process? All right, so what we do it, one way to do it is by sample size. So if you have only 3 people in the study, you most likely did not do enough talking to people to really warrant a good experiment. And that's, oh, well, then you can repeat the study. That's the other thing. Can you just repeat the study 3 or 4 or 5 times over? And if you're still getting the same results, then hey, that looks like it's happening. Okay. So sample size and replication, kind of there it is. The replication process experiment is sometimes we can't do the experiment over again. Sometimes when things are gone, it's gone, right? So before the elections, we take a whole bunch of polls, right? And then once the election is over, you're done. We can't do that anymore. So replication is just a repetition of experiment. And usually what we do is we just use a large number of subjects. So testing a vaccine strain or the flu, 10,000 people are given the vaccine, 10 others are given a placebo. Because the sample size, the effectiveness of the vaccine would not most likely be observed. That's a lot of people, though, right? Isn't 10,000 people a lot of people? How come? You guys talk to me. How come 10,000 people? Okay, sorry. 10,000 people would be a good sample size, right? 10 people probably would not. Okay, so there it is. All right. Let's go through just quick a few things here. I'm going to give some examples. Let's talk about it. Don't need to write them down. But here it is. The company wants to test the effectiveness of a new gum developed to help people quit smoking. Can you guys identify a potential problem with this experiment design? What's the issue? Is it a control issue? Is it a randomization issue? or is it a repeatability issue? So the company identifies 10 adults who are heavy smokers. 5 of the subjects are given new gum, the other 5 are given a placebo. After 5 months, they evaluated and it's found that all 5 subjects using new gum have quit smoking. This is awesome. This is the best thing. This is the golden grail of gum. It's 100% effective. Issue? Go ahead, Edu.
If they told them that
Gotcha, yeah. So it doesn't say if they told them or not, right? It just says 5, and we're given 5 dots, so we don't know how they. So just, but based upon just the words on the screen, what's an issue there? I think the number is the problem, right? 5 people is not going to give you any information right here. Duh. Okay. All right. So now they repeat the study, or they do another one here. Now they're going to give you guys parked on them, saying 10 people is not enough to do anything, guys. I'm going to look at the study. So then we have this one. Company comes up and says, okay, fine. We're going to look at 1,000 adults who are heavy smokers. They're going to divide them up into 2 blocks. And after 2 months, the female group has a significant number of subjects who quit smoking. This is a little more difficult. Click on there. What do they not do correctly?
didn't specify if it was if the people group was significant in one block or in both blocks.
I think that you were getting there, yeah, absolutely. So the issue is, why in the world would you divide up into females and males and that's it? Because the random block design is this. If you're going to do it by gender, right? Then within each gender, you're going to have a control group and a treatment group, right? Because you want to find out the effects there. So it's the random block design was done wrong, really. Groups are not similar. New gum may have great effect with women, but that's not the study. The study was supposed to be divided into groups, and then by each gender, then randomly sent. Then that would have been okay. Okay, so we have randomization of block design, right? So kind of think about it. Randomization is this whole concept of how do you build the experiment, right? Now sampling is now how we're actually going to build, how we're actually going to pick those people now. So how do you pick people for the control group? That's kind of what we're looking at now. And so we've got to go back in time just a little bit here, guys. So sampling as a whole. So big picture. So let's zoom out to the big picture here. So remember how last time I said we make a huge difference between population and sample. Those things are totally different from each other. If you can get data for the whole entire population, that's one thing. If you get data for a sample of a population, that's totally another. So big picture is this. If you're going to get data for the whole entire population, we call it a census. Okay, we have that every 10 years, right? The US Census. It's supposed to count the whole entire population. If you're going to count only part of the population, we call it sampling. So sampling is just counting a proportion. That whole bunch. That's the one that's the experiment design stuff right there. We normally can't talk to every single person on the face of the planet. And then we have one thing that occurs. Here it is. even with the best possible sampling methods, we have come to the conclusion that we're going to have some kind of error in our data. That sample is not going to feel the exact data of the population. So we have to always account for sampling error. The way we accounted in our formulas. When we write these formulas down, we also accounted in our analysis. And we say, okay, but it could be that this had this much sampling error. Okay. Good there. So how do you pick the control group? How do you pick the treatment group? Here we go. One way to do it is just a random sample. In fact, this is the goal. The goal is to get a random sample. So if we block those smokers, the heavy smokers, into male and female, now the question is, how do we pick the females randomly? How do we pick the males randomly? And so on, again, go on YouTube. Sometimes you'll have people like, this was not a random sample. Which I'll be the first thing that they'll sort of say. The data is skewed. This was not randomized at all. You took a biased sample. And so how do we get a random sample? What's the whole point of getting a random sample? Oh, sorry. Okay. Change the slide just a little bit here, so your slide might look different from mine. There's the goal. Random sample is the goal. Every single person has a chance to be selected. So the first way we do it is something called a simple random sample. Your stuff is a little different than mine here. But every possible sample of the sample size has the same chance of being selected. How do we do so? We usually incorporate some kind of software. I could put you guys all your names into a hat, right? And I swirl the names around and I pick the sheet of paper out. That would be a random sample. We don't really do that to look at so much people. What we normally do is we pick we use software, calculator or software program, and we make a random number generator. Pick it. Normally, we assign a number to each person in the population, and then with the random number, we pick those people out, and we are good to go. I think let's see, the U.S. draft is an example, right? Guys, if you turn 18, or if you had to fill out, right, U.S. service. And then what you do is when you get that, your name becomes a number, and it's just sitting there. Right? So we call a draft. So the draft is random. Random, supposed to be as random as possible. So is jury duty. Jury duty. Anybody raise your hand if you went on jury duty yet? 1, 2, 3. Huh? Half. Half of jury duty. Okay, so 3 of you guys. And so
I have a question.
Yeah.
What is that?
Jury duty?
Yeah, like how old do you do that?
I think once you turn 18, your name is listed as an adult in the community, and your name just pops up because it's a random selection. And so you get a letter in the mail saying, report to this, and if you can't, you can have up to a year extension, but then within a year, you have to show up for jury. So everybody has to do that, yeah. This is kind of fun thing about being evaluated by your peers. So then my mother-in-law, she's been selected 3 times already. And let's see, I've been selected once, my wife been selected once, and nobody else that I know in my extended family has been selected. So there's your randomization. So how about that? 3 times. Okay, let's jam with this one here. So let's see. How do we do this? We can skip this one here. This is just kind of. Okay, just real quick here, just so we know. So if I were to select, this is kind of like homegrown stuff. 731 students that are enrolled in statistics class in your school. You want to sample 8 of those people. How would you do it? Well, you would select 1 through 731 somehow on a calculator or something like that. You choose them. You can pick them out of a hat if you like, right? So you're doing that. The way it's normally done in, we're trying to randomize the randomization. That's kind of weird. Let's take a look at this. This is kind of crazy how we do this. This is called a randomization table right here. Good. So what we do, these are just random numbers. They're trying to be so that all the digits show up about even throughout this whole table. And so what you do as a person that wants to select this, what do? You just pick randomly. You pick a column and you randomly pick a row. Just pick it. That's it. Because there's your randomization. And so let's say someone picked this one right here. That's it. We're going to pick the 3rd column, the 3rd row randomly. So now we have 731 students, don't we? 8. So what we're going to do is we're going to pick 3 digits at a time. So notice from the 7, count 3 digits. 719 is first 3 digits. We're going to ignore any number that's above 731 because it doesn't name a student, right? 731. So we start butchering those numbers. So every 3 numbers, or every 3 digits we count. So 719 is 1 3-digit number. 662, are we good there? We cut it off there. 738 is the next 3 digits. 650, 004, and it just goes down the line. Are we good? So then what we do is we just cut off anything that's above 731. So this one does not mean anything, but student number 719 is going to be selected. Student number 662 will be selected. 650 and student number 004 gets selected. And so there's your randomization table, and it's a random column, random row, and then random amount of digits. So we try to figure out that's about as non-biased as we can get. Okay, so there it is, simple random selection. We used quite a bit. This is probably the most amount of way we do stuff like that. All right, the other one. The other one, something called stratified sampling. So we divide our group into more groups. And then from there, what we do is we randomly select the person there. So again, it's stratified sampling. And then at this point, because the groups are so small, now you can put them into a hat if you like, right? Or if you want to select them, you could do a random number generator, right? But at first, what you did is you stratified a sample. So do you guys remember the weight loss program that we were on, right? They blocked them into what, 30 and 39-year-olds, 40 and 49-year-olds, right? And 50-year-olds plus, right? So within that sample, the question is, I'm going to stratify those into, oh, this will be good. How about how active they are, right? That would be a good one for a diet program, right? So you're going to divide the treatment group and control group into how active are you? Do you run? Do you jog? Right? Do you go to the gym? Right? And then you can randomly select those inside that sample. So it's-
You live.
Correct, yeah. yeah, because that's going to influence your diet program, right, or whatever, or the diet plan. So that's kind of so it's a stratification. I think that's one way to do it. The other one is something called cluster sampling. Cluster sampling is you divide the population, whatever you're trying to work with, divide it into groups. At this point, you're going to select one of those, and just those you're going to survey. So this one not used a lot because you somehow have to prove that the people that live in zone 1 are very similar to people that live in zone 2, zone 3, and zone 4. So there's no difference between those people. And so you got to think about this right here. Let's say zone 1. Let's say zone 1 is a city, right? And the neighborhoods are very close together. Okay? How about zone 2 is going to be a rural area of town? And so because of this, going to be differences already, right? Like, you should not test how far people drive to work. Because if zone 1 is a city, most people will drive, it's a small city, right? People are just going to drive to work within 10 minutes, right? If zone 2 is a rural countryside, that means people there actually are driving to work a lot longer, right? Driving into the city. So that would be not a good study. You somehow have to prove that people that live in all 4 zones are pretty much the same. Yeah, this is why it's not used as much. This one's more like, this is a good one, like cholesterol medication, right? Like humans are humans, right? It's not going to matter if you go to the country, to this one, whatever, right? So eye color, you know, something along those lines where like it's just a human trait. This one probably gets the most amount of scrutiny, saying, hey, this was not a random sample. You picked this zone for this reason, that's why. Okay, so cluster sampling. Usually what's done here is because you're trying to get a lot of data and you're trying to use it for the least amount of money, right? Because you can go door to door in zone 1 if it's a neighborhood, right? And getting data. Zone 2, if everybody's living 3 miles apart from each other, you're gonna rack up a mileage bill. That's gonna be crazy, right? And so usually we do it for that. It's a cost-effective strategy to get information. Okay, and last one here. Systematic sampling. Oh, sorry, 2 more here. Systematic sampling. It's too tough to do the whole entire population. So what I'm going to pick every 5th person in the population. I'm going to pick every 10th person in the population. And so they have to somehow you have to order them somehow. And we go from there. That's usually done if you want a certain amount of people in the study. Right? That's usually like, I need 100 people in the study. I have a population of 1,000. Therefore, every 10th person, I'm going to do this. Fun fact, here it is. Let's see. There's a test everywhere. In the cafeteria, once a year, the director of the cafeteria, he does a survey about if the students like the food, if there's enough variety of food, if they, you know, kind of the questionnaire for that. And so I think what he does is he goes every 3rd person. So every 3rd person that walks through that door gets a survey. Like, here's your survey, fill this out before you get in line. Right? So that's a way systematic survey. Because if you were to do everything, everybody, a lot of papers, right? 300 papers, right, to look at. But you figure, look, every third person, I scrunch down to only 100 papers that I need, but most likely we'll get the same data. Okay, and then one last one here, and this one here just is, sometimes it comes to this, convenience sampling. You choose members that are easy to get. That is, let's see, that's people standing out of Walmart, right? And you're walking into Walmart and they say, hey, would you like to do a quick survey of 3 questions for me? They're asking you. You can refuse to do so if you like, as opposed to the people that come to the cafeteria. The director has a little foothold there. You don't get food until you fill out the survey. So that means you're going to fill out the survey. So convenience sampling, see who you can get. All right. Just a quick ones here. So not recommended, obviously, because you're not going to get a good, nice randomization of this process here. So let's do this here. Tell me which sampling technique was used in this. You divide the student population with respect to majors, and then you randomly select and question some majors in each category. Divided according to majors, the psychology, biology, health science majors. Top two. Thumb through your sampling techniques here. Starts with S. I go stratified sampling, right? There was at least some kind of organization there. And then randomly select the ones in that organization. I was stratified sampling. Okay, and then next one here, I think we have one more here. You assign each student a number and generate random numbers. You then question each student whose number is randomly selected. Student. This is starts with an S. I think I've heard it, right? Simple random sample, right? You're auto-generating them. You're trying to randomize it as much as possible. Maybe do it by a table of sorts or something like that. And then the last one here, number 3. How about this? You just select students who are in your biology class. Convenience, absolutely. You're not going to test the whole school, even though that's maybe what you need. But it's a convenience sample because they were just available in the class that you're sitting in. Okay, class, let's go with it here. Let's see, I have. Let's take a 10-minute break. For now, let's regroup at 50. You know, I think that the dude, what's up with that? Okay, chapter 2, something called descriptive statistics. So we finished up chapter 1. Chapter 1 was how do we randomize stuff, how do we do observation or experiments, all the good stuff here. Now chapter 2 is about what happens when we actually bring in the data. We've got the data in front of us. What do we do? And this is something called descriptive statistics. This, in fact, if you want to kind of think about it, our courses, chapter 1 is kind of like intro, right? Chapter 2 was one side of statistics. This is descriptive statistics. We'll take one chapter to do these guys, right? We're going to take a big old break. And we're going to do chapters 3, 4, and 5, which is probability. Way different. Good. It's like, it could be its own little class if we wanted to do it. Okay? So chapters 3, 4, and 5, own little class, it's called probability. And then what we do is we come back to statistics in chapter 6, and we do something called inferential statistics, which means I look at the data, this is what I think is happening with the population. That's kind of different. So this is just not population, this is like number crunching right here, displaying a number crunching. So let's jam. So something called frequency distribution. Most of the time we look at data like that. And any data that you've seen looks like that, as well as their graphs. And then 2.2, more of the other types of graphs we use sometimes in stats. 2.3 is going to be figuring out what is the middle. Where's the middle of this data? And we do 3 different things to find that out. 2.4 is going to be how much variation do we have? How wide is this data? And then 2.5 is going to be the position. What's the individual's position in the data? All important stuff. We use it quite a bit. Let's jam with it here. So 2.1. And on your notes, I think you should be able to see that some things are blocked off and you actually don't see numbers there. That's where you goes to write it. So we'll kind of do with that. Okay, so frequency distribution of the graphs, let's jam. And for these ones, I'm not sure if you just want to write in on notes or not, kind of do it that way. Not so much definitions here anymore. This is now more of just calculations. So it's a little bit of a different flavor to the notes. Okay, let's jam. I'm going to go for it. So first things first, frequency distribution, what we do is we divide things into classes. Some people say they call them intervals, but we divide them into sections of stuff. So class 1 through 5. Means, and then what we do is we count up the number of times that occurs in that space. We good there. So if it's explanatory, we're going to go kind of quickly, okay? Because you have notes in front of you. You're just going to jam. So frequency is the second table, how often that occurs. So this could be ages of children or ages of people in a certain wedding or something. I don't know. So right, you got the 1 through 5-year-olds. There's 5 of them. 6 through 10, there's 8 of them. So it's just a build up of things. Okay, jam, let's go. Just kind of real quickly here. So first things first is vocabulary stuff. That little piece right over here is called a lower limit. The lower limit to our class. The stuff on the other side is going to be the upper limit. Just some vocabulary. There it is. I'm going to highlight it. Some people are doing that. If you just want to underline it, that's cool too. So vocabulary, stuff we're going to use. Next. Next is the whole concept of a class width. How wide is a class? And the class is wide by not going from the start from the lower to the upper. It's actually from the lower to the next lower. Right there, so we actually go down each class. So 6 minus 1 is 5. The class width is 5 each time. Now you can subtract either the lowers if you like. You can subtract the uppers if you like. Doesn't matter, right? Because 10 minus 5 is still 5. In fact, anywhere you do this, you still get the same answer, right? 26 minus 21 on the lower bottom here, 26 minus 21 is still going to be 5. Cool. And then the range. The range is just the highest number we have minus the lowest number we have. We'll do that in just a bit here. So there's the range that we're at. So let's do this here. I know kind of quickly here. Let's actually set up a frequency distribution through our notes here. But first, just real quick before we do that, let's do this here. Oh, actually, okay, let's jam. So here's what I got. A list of data. This is out-of-pocket people that paid for their own medications in 30 US adults in the recent years. So this is 2015. This is from the Health of the United States. So this is actually real data. It's kind of cool. We get to practice real data. Question is, can we set up a frequency distribution that has 7 classes? Now, the question is, like seriously, why is it 7 classes? In stats, we range anywhere from about 5 to 20 classes usually. Because what happens is when you see this data right here, oh, sorry. It's all gibberish, right? You can't make sense of the data, right? So you want to kind of put it into some kind of pattern, some kind of sorts. Most of the time, I've seen data that I've seen, it's anywhere between like 10, maybe 12 to 7. 12 to 7 classes is usually the good sweet spot. If it's humongous data, yeah, you can go out to 20. If it's very small data, you can go down to 5. So kind of depending on how you do it. So it is a way for us to see patterns and see what's happening with the data. So let's jam. So here's what I got. Number of classes, we said is 7. The 7 that was given to us already. Okay, and then the first second thing we need to figure out is our class width. What's our class width going to be? Now we just did it on the previous one, it was already given to us, but this is the way we determine class width. Ready? We're going to figure out the range. So what is my range? And then divided by how many classes I want to show up. This one you want to write down because I blocked it off. You can't see it in place. So let's see, what's our range? What's the highest number you guys see over here? I think, yeah, 405. Anybody see something higher than 405? Nope, I don't see it. Okay, anybody see that? What's the smallest number we got? 165, I heard. 165. 155. Oh yeah, 155 in the top corner over here. Boom. Okay, let's go with it. Max minus min. So 405 minus 55, and how many classes we wanted? 7. We wanted 7 classes there. So 405 minus 155 divided by 7. All right, so we can get out a calculator. That's good. So 250 divided by 7. That's going to be approximately 35.7 about as we divide it out. So now the question is, what do I do with this number? Some students, some statisticians say we round down, some say we round up, and we're just going to round like we normally round in mathematics. So 35.7 is about 36. So here it is. What's our class width? It's 36. Okay, so now let's set up our lower bound and our upper bound. Good. Tell me if I'm going too fast. We're good. We're just going straight on this, and that's it. Okay. So here it is. My lowest point is 55. Notice I have 2 columns here. Eventually, we're going to make them into 1 column in just a bit. But just to sort of get our mind here going. So 55. Our class width is 36, so therefore we're going to add 155 plus 36. That's right. You want to get out your calculators. 191. Whoa, that's cool. 191. Anybody? 191 plus 36. What's the next one? It's 191 plus 36. Try to get out some calculators. 227. Okay, try it. 227. Then adding 36 to that one gives you 263. Adding that one gives you 299. Adding 36 gives you 335, and adding that one gives you 37. Okay, those are all lower limits. We've built them up. We are done. We are good. We're good. Next question is, how do we develop our upper limits? Any suggestions? Cool. Okay, we can do kind of one of 2 ways here. We can go plus 35 this way, right? Just one time. We have plus 35, or we can take this 191. We could just subtract 1 from it, and now it should give us 190. Are we good? So now you can either add 36 all the way down. You can subtract 1 from your lower limits each time, whichever one you like. We're good. All yours. Give you guys 30 seconds. Try it. Go for it. Add 36 to 190. And keep on adding 36, or just subtract 1 from each of the lower limits. But then you got a little problem right at the end. You're gonna have to add 36. Are we good? Just making sure. All right, so I'm going to subtract 1 from each of the upper limits. So 227 makes 226. 263 makes 262. Then we got 298, 334, 370. And then the last one here, 370, I'm going to have to add 36 this time. 370, adding 36 gives me 406. And done. 10 minutes. Let's see. Get to 10 minutes. Okay. Very good. Upper limits, lower limits are all good. Jam with this one. Now let's go back to our data. So here's what I want you guys to do. Go back to your data because you're going to have it there and your sheet of paper here. Can you tally mark the number of times those things occur? So tally marks usually the first way we start it. So if you look at your data, you should see three numbers that are between 155 and 190. You good? Let's do it quickly. Each one of you guys do it here. Let's do it. You guys stay on this page. I'm going to go back to my data page. All yours. Go for it. So I got 155. I have a 165. And 168 right here. There's my. And then if you want to, you can just kind of cross those out if you like. That's fine too. All right, so once I get this, I go like that. I go like that. And I go like this. Or you can go one number at a time, right? Put tally sheets. It's actually easier to do it this way. Just say 200. 200 falls where? And put a tally mark there. Then 239 falls where? And put a tally mark over there. So just real quick here, let's go with tally marks. 45 seconds. Go. So putting tally marks on your page, which looks like this. You're putting tally marks in here. And if you, when you're done doing all the tally marks, then just count up the tally marks, put that number right over here. Boom. Go back to here. So here's your data. Go for 200 will fall somewhere. 239 will fall somewhere. 252 will fall somewhere. 40 seconds left. After you've done that, and very confident that you did it correctly here, count up the tally marks, put it in the next column. That will be your frequency. Here's what I'm going to go for. Here's what I got. That one is this one, and I got that right there. Are we good? I have 3 for the first one, 2 for the next case. I counted 5. That one 6, and then 7, and then 4, and then 3. Sorry, guys, we have 5 more minutes left, and I'm going to get to about 7 slides later. Quickly, a few things here. And don't want to go too fast for you guys, so talk to me. Are we okay here? Okay, now the question is this. If you count up all the frequencies, if you just write them up, so 3 plus 2 plus 5 plus 6 plus 7 plus 4 plus 3, what should you get as a sum on the bottom there? How come 30? Same number of data points we had, absolutely. So there's a little Greek notation. We use Greek capital S. It's called sigma. That's what it looks like right there. And so the F means frequency. So it's the sigma, or the summation of all the frequencies is 30. And it's really pretty much like a little check for us. We check to make sure we got all the data, because we add it to all the data points. Okay, I'm gonna just quickly, are we all good there? Anybody still need more time on this one? Okay, let's jam just a few more things here. So Then the question is, what is the middle of each of the classes that we have? And that is something called the midpoint of the classes. And I give you guys the, yeah, I give you guys the value for it here. So lower limit plus upper limit divided by 2. So the first one would be 155 plus 190 divided by 2 is 172.5. That's cool. Once you get the first one, you can just keep on adding 36 to get the next one. Very good. So that is the midpoint. Very important stuff. Very important as we deal with calculating like the average of things and stuff like that. Okay, so if we do that, you guys tell me when you have blanks in your slide here, okay? So then we talk about something called relative frequency. How often does something occur relative to the group? Or what's the portion or percentage of the data that falls in this particular class? All right. The formula for it is you figure out the class frequency. How many times does the class occur? And they divide it by how many you have total. Okay, good there. I think I give you the formula for that as well. So that's cool. Okay, cumulative frequency. Let's jump to the next one. Cumulative frequency is that you're just adding up all the stuff together. So you want to go from 0% to having 100% of the data. And let's fill out one more chart as we go here. So there it is. So people writing down the definition. Wait a little bit here. Okay, so let me show you the midpoints of each of this of them. We'll jump them into the table and we'll finish off what we at least want to get to today. Cool. And so what we do is we find the midpoint of every single thing here. So let me give you the midpoints here. So on this slide over here that you guys have, now we've kind of built up the table completely. So jump to that slide on your notes here. And so we build up the classes, right? Those are the expenses that we had. We now have the frequencies in front of us. We don't need the tally marks because tally marks was just to kind of get us to the point, right? Some of the times we actually just use Excel spreadsheets to push them in because the data is so big. All right, so the midpoints I don't think you guys have if you want to write those in. 208.5, 244.5, 280.5, 316.5, 352.5, and 888 or 300. There's no need to add up the midpoint. It doesn't make sense. There's no data that comes off of it at all. There's no check that we do. So now the question is what's the relative frequency? How often does people in this class right here happen relative to how many we have altogether? So notice, let's see, 3. What is 3 out of 30 anyways? What do you guys say? How much percent is 3 out of 30? 10%. You got it. So if you punch in a calculator, you put 3 divided by 30, you should get a 0.1. So we know that to be 10%. Okay, running out of time, so I won't torture you as much. So all we do is we just say 2 divided by 30. We go 5 divided by 30, 6 divided by 30, and then we put them into decimals. Okay, you guys, sorry, ask a question. Okay. Bam, with that, now we have something called cumulative frequency. Whenever you hear the word cumulative, it means you're adding up from the previous stuff. So the first one, and we start off with 3 here. There's only 3 totals over here. Then what we do is we start adding up the next one. So if 3 is here, if I add 2 more in class, second class, I have 5. 5 plus 5 makes 10. 10 plus 6 makes 16. 16 plus 7 makes 23. Add 4 more to 27. Add 3 more to 30. And you better get a 30 at the end, right? You have all the data. one other thing we actually add up as well is the relative frequency. Anybody have a guess here? What is 0.1 added to 0.7, 0.17, 0.2, 0.23, 0.1? How come 1? Perfect. Relative frequency is technically almost like percents, right? It's 10% here, 7% there, 17%. So eventually it should add up to 1, or else you're losing some data. You got some data there. So you made a miscalculation. Okay, I'm going to stop there for today because we're running out of time as well. So that is the frequency table right there. We're going to do a lot more stuff with it next time. Good. Just show of hands here. As I printed out the notes, was that too small on your notes, or is it just the right size? So let's go raise the hands. Raise the hand. It says too small. Mr. G, that was too small for me. 1, 2, 3, 4. How many say it was just right? The size was just right. It's okay. I can write it. 2, 3, 4. It's a tie. 4 to 4. Okay, we're out of here. Thanks, guys. I'll see you guys on Tuesday. So let's see. You probably don't. You can try 2.1 homework. Try a little bit of it, like setting up a frequency table. That's kind of as much as we got. But you probably won't be able to finish 2.1. For the rest of your day. Enjoy Monday, and I'll see you Tuesday. See you soon. Right? Yeah. All right. Fine. There's no one's flipped over this yet. Fine, what's up? How'd you get? That's on and then G. Oh, on G. On G. On G, yeah. On G, yeah. Byron, I'm so sorry. It doesn't have a name. Byron, B. Spell it for me, please. B-Y-R-O-N. Byron, B-Y-R-O-N. Byron. Let me say that. Byron. Okay.
I have a question about the book. And like, can't it be like a 28? So when that was like published in 2018? No, I did get it the same model number and brand it was. I did, but it says 2018.
That is weird. Does it look like this with a white cover? Or is it a blue cover?
No, it's just like that.
It's the teacher edition. As long as it actually says 7th edition.
It says that.
Yeah, as long as it says this and it's the same Larson and Farber. Okay, did I have 19 on there?
No, I mean it is right what it said. It's a 2019 edition, but I only found one that's 2018 edition.
Yeah, usually they change every 5 years. So usually would have an edition like 2018, 2013. You would not have 18 and then a 19 edition.
Oh.
So that's weird. Maybe just the date that they were advertising, they messed up on.
I also have a question. How does the tutoring start?
Oh, sure. Walk in the library, they'll have you fill out a little form, and you're good to go. Find out the tutor times for people that teach MATH 25, and you just have to sign up. It takes like 5 minutes to sign up.
Oh,
You have to sign up technically for a class because they want to track you when you come in. So you walk in the library, they'll have a sign-up process there, and then you go see a tutor. Just find out which times they are.
okay.
They have that. So here's kind of like step process here. So register for NCE 100, which is just a tutor. So a shell, you'll have another class listed next to the classes. That's kind of announcements, change your schedule, stuff like that. All right. Go to tutoring, with times. Oh. Online tutoring for 2025. Oh. So they actually have a tutoring session, right? June is after class. I would say there's tribal tutors. Online tribal tutor. Some people are working in person, you don't work there with another person, right? So you have, just try a combination and see which tutors you can do. It's very important to, especially tutoring, very important to get a sense of the person and how they interact with you. And if they make you understand the material easily. We good?
And it's just at the library.
Yeah. Walk in, they'll register you for NC 100 and you're good to go.
Oh, okay. I also have when we're taking the test, how would it be? Like what materials?
Oh, I will give you guys a study guide for the test. I'm sure about halfway through chapter 2. The study guide. There's not a speaking yet. There's pretty much 4 questions on the study guide. Those are the questions on the test. Except the study guide, I don't need you guys the numbers. I'll say like finding class with. You should know.
Oh, so it's like no notebooks.
Oh, sorry, not for the test. You get one sheet of paper, and you can write down whatever you like on that sheet of paper from anything you learned from chapter 1.
Oh, just one sheet.
One sheet, front, side, write whatever you want.
Oh,
And those you keep, because then you get to, we're going to do 4 exams, actually 5 homework sessions. So as you come to the final, you'll have 5 sheets that pretty much are all there. So that's kind of the way I said that. Good, does that help?
yeah.
Cool.
And
Let's turn on that.
just a quick question.
Yeah, sure, go ahead. Absolutely.
I was actually confused on this part when we were supposed to do it to like no when we were supposed to like find the tally marks. Wasn't it from no just that you showed us like when to find the tally marks. You showed like several series of numbers to find them there, and I wasn't sure like how do we find them through this sample. Yeah.
Oh, okay. So that was just data given. I said the data set below is this. So I gave you the numbers.
Oh.
And then we were supposed to do this, the frequency distribution. Are we good there? So these are the data, right? And then what we did is we made our table. We counted the frequencies and then we added up 30 to make sure that we had, because it said that we had 30 things here.
Yes.
So we added up to make sure we added up to 37.
Oh.
Is that your question, right? Okay, okay. So make sure that. Did I answer your question? Ask it again if I didn't answer your question. I feel like I did not answer your question.
Okay. How about we lay out this?
Gosh,
It's just that no.
yeah, right here, right?
I mean, I was paying attention like how you will get the tally marks, and Okay, so you said that you find it, you just mark it down by the number of frequency.
Yeah, so let's see, so we're here, all right?
Yeah.
And let me go to mine. Oh, I'm still recording. That's not good.